Voyager 1 spacecraft sent back pictures of man's closest look yet.
T-minus 15 seconds. Guidance is internal. 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
In the vast expanse of the cosmos, human ingenuity has propelled us beyond the confines of our home planet, unlocking the secrets of the universe through the exploration of space. The Voyager spacecraft, representing humanity's exploration, has traveled deeper into our solar system than any previous missions, providing remarkable insights into the wonders of the cosmos that envelop us. However, a recent development has sent shockwaves through the scientific community. Voyager 1 has transmitted a message that has left scientists and space enthusiasts on edge. But what dark secrets does this terrifying message from space hold, and how will it forever alter the course of our cosmic journey? Join us as we embark on a journey to unravel the implications of this unsettling message that Voyager 1 has just dispatched from the depths of space. Voyager's grand entrance into interstellar space. For almost 5 decades, the Voyager missions have been like the unsung heroes of space exploration, offering us some of the earliest and most eye-opening glimpses into the vast wonders of our solar system. Surprisingly, these missions were never designed to stand the test of time. Back in the 1970s, the whole idea of sending out probes was stumbled upon by Michael Minovich. It was a joyful moment when he realized that a spacecraft could hitch a ride on a planet's velocity and catapult itself deeper into the solar system. Initially intended to last a modest 5 years, the Voyager mission has far exceeded expectations. Voyager 1 and Voyager 2, launched just weeks apart in the summer of 1977, were initially set on a mission to explore Jupiter and Saturn. Mission accomplished. Both spacecraft successfully conducted studies of these gas giants. But here's the kicker: they didn't stop there. Voyager 2 went on to achieve the remarkable feat of making the first ever close-up observations of Uranus in 1986 and Neptune in 1989. These flyby trips, covering the quartet of planets, earned the missions the catchy title of the Voyager Grand Tour. Far from calling it a day, the resilient Voyager duo then set their sights on an even more ambitious mission, delving into the uncharted territories of deep space. So, here we are, 46 years later, with Voyager 1 and Voyager 2 still on the move, diligently gathering crucial scientific data from the farthest corners of the cosmos. In a revelation that could make your interstellar day, NASA dropped a cosmic bombshell in 2013, announcing that Voyager 1 had officially crossed the threshold into interstellar space. Now, if you're not up to speed on the language, interstellar means the space between stars, the real deep end of the cosmic pool. So why is this boundary significant? Well, according to the brilliant minds at NASA, interstellar space kicks in when the sun's constant stream of particles and magnetic fields decides to take a breather. It's like the space version of leaving the solar system's bustling neighborhood and entering the serene, star-studded wilderness. Hold on to your space helmets, because the Voyager saga didn't stop there. Fast forward to 2018, and Voyager 2 decided to join the interstellar party, making its grand entrance into this vast expanse when it was a whopping 17.7 billion kilometers away from our life-giving sun. What's truly mind-blowing is that as of now, Voyagers 1 and 2 remain the only spacecraft to have braved the uncharted waters of interstellar space. These interstellar pioneers haven't just been stargazing, though. They've been busy investigating the nitty-gritty details of how the interstellar medium rubs shoulders with our sun's charged particle-packed solar wind. But wait, there's more. The dynamic duo has been our go-to source for intel on the heliosphere, a protective bubble wrapping around our solar system. The solar wind, a continuous flow of charged particles from the sun, sculpts and tweaks this heliosphere, and Voyager 1 and 2 have been our cosmic correspondents, beaming back insights on this celestial force field. And where does it all come together? Well, the official frontier of our solar system, the spot where the solar wind waves goodbye and interstellar space throws its arms wide open, is known as the Heliopause. It's like the cosmic handshake between our familiar solar neighborhood and the great unknown beyond. Unraveling the cosmic secrets of interstellar noise. NASA's Voyager spacecraft has been a treasure trove of fresh insights into the mysteries of interstellar space. One standout revelation? Cosmic rays, those elusive particles, are flexing their cosmic muscles 3 times more intensely beyond the heliopause than within the cozy confines of the heliosphere. It's like comparing the quietude of the solar backyard to the bustling cosmic street just outside. But wait, there's more to this celestial soap opera. The brilliant minds at NASA didn't just stop at Voyager's revelations. They seamlessly blended data from subsequent missions with Voyager's findings, creating a cosmic collage that gives us a more complete picture of our sun and its intricate dance with the surrounding interstellar space. In a cosmic symphony last year, NASA scientists dropped a bombshell. Voyager 1 recorded a humming noise echoing the waves detected in tiny amounts of gas hanging out in the near-empty expanses of interstellar space. Imagine the Voyager as our cosmic DJ, spinning tunes in the vastness of the unknown. Nicola Fox, the head honcho of NASA's Heliophysics Division in Washington, D.C., in her own words, "Over the last 46 years, the Voyager missions have been critical in providing this knowledge and have changed our understanding of the Sun and its influence in ways that no other spacecraft can." Now that's one heck of a space odyssey. Here's the kicker. Voyagers 1 and 2, those plucky space explorers, are powered by a plutonium-based thermoelectric power system. But as the plutonium gets its groove on, the heat production takes a nosedive, and the Voyagers start losing power. In a cosmic power play, NASA had to make tough decisions, turning off non-essential and even some initially considered necessary systems. Heaters, designed to keep instruments cozy in the frigid embrace of space, were powered down. Yet, surprise. All 5 instruments have been rocking and rolling since 2019, defying the odds. NASA experts are scratching their heads, pondering the cosmic mystery. How on Earth, or in space, rather, are the Voyagers still operational in temperatures that would make any other spacecraft shiver in their metal boots? It's a mystery that adds another layer of awe to the enduring legacy of these intrepid space pioneers. The solar system's outskirts are throwing us a cosmic curveball. Picture this: the Heliopause. That cosmic barrier between the heliosphere and the interstellar medium is dancing with its own. It's not just a static boundary, it's rippling and creating unexpected oblique angles, leaving scientists scratching their heads in awe. This whole concept of the Heliopause being a shapeshifter isn't entirely new. Over the past decade, savvy researchers, armed with data from the dynamic duo Voyager 1 and Voyager 2, along with NASA's Interstellar Boundary Explorer satellite, have uncovered the Heliopause's penchant for change. These spacecraft are the unsung heroes, providing the only direct in situ measurements of these cosmic boundaries, even if it's just at one specific point in space and time. Now, here's where it gets even more intriguing. Recent research has thrown a curveball at established findings. IBEX, the cosmic detective, documented a peculiar brightening of energetic neutral atoms in 2014, suggesting some funky asymmetries in the heliopause. The scientists later found that these asymmetries didn't quite jive with their models. It's like the cosmic scriptwriter decided to throw in an unexpected plot twist. But wait, there's more. Scientists observed the heliopause making substantial moves in a surprisingly short span after diving into data from Voyager 1 and Voyager 2. This movement could explain the significant time gap between the two probes venturing into interstellar space in 2012 and 2018, respectively. The Heliopause's antics are not just confounding, they're downright contradictory to existing theories. In a bold move, researchers labeled these disparities entry-speaking in an article published in the journal Nature Astronomy on October 10th. Translation: it's a bit of an enigma and could potentially stir up some cosmic controversy. But fear not, the quest for answers doesn't end here. Scientists plan to delve deeper into the mysteries of the Heliopause, eagerly awaiting insights from NASA's upcoming Interstellar Mapping and Acceleration probe. This state-of-the-art satellite, set to debut in 2025, promises to unravel more secrets from the ghostly depths of our solar system. Until then, we're left to speculate on the cosmic riddles unfolding beyond the Heliopause. Voyager's electronic confusion and the celestial fix. In the middle of May 2023, Voyager 1 decided to add a cosmic twist to its usual routine. The onboard system responsible for the spacecraft's high-gain antenna, aptly named the Attitude Articulation and Control System, AACS, started sending back a confusing jumble of data. Instead of the usual spacecraft health and status reports, we were receiving what seemed like the interstellar equivalent of electronic aphasia, a condition impairing one's ability to speak fluently. From our earthly standpoint, it looked like Voyager 1 had caught a case of electronic confusion. The data streaming back seemed random, or maybe it didn't reflect any coherent state at all, at least according to NASA's explanation at the time. What made it even more puzzling was that, despite these bizarre updates, Voyager 1 looked to be in top-notch condition. The radio signal from the spacecraft remained strong and consistent, suggesting that the antenna was still dutifully aimed at Earth, contrary to what the AACS claimed. Adding to the intrigue, the scientific instruments on Voyager 1 continued their data collecting and transmitting duties unfazed, completely unmindful of the oddity happening in the AACS. Moreover, whatever quirk was going on didn't trigger the fault protection system designed to put the spacecraft in safe mode during glitches. Thankfully, the sharp minds at NASA were on the case. They identified the problem. Turns out the AACS had been using an onboard computer that had been on permanent vacation for years. The solution? A simple command to instruct the AACS to switch to the functional computer for data transmission. Easy, right? Well, not quite. The snag in this space tale is figuring out what prompted the AACS to play this cosmic version of musical chairs in the first place. According to NASA, the system likely received an incorrect command from another onboard computer. While they assure us it's not a grave concern for Voyager 1's current well-being, the hunt is on to locate and fix the root cause to avoid any future cosmic oddities. It's a celestial mystery that keeps our cosmic detectives on their toes. Voyager 1 has been charting the cosmic seas in interstellar space for the past decade, far removed from the protective cloak of our sun's magnetic field. This magnetic shield, akin to Earth's protective magnetic fields, served as a cosmic barrier, fending off cosmic rays and other interstellar radiation. It's like the spacecraft's very own celestial suit of armor, safeguarding it from the harsh elements of the cosmic frontier. Now, let's talk tech. Just like high-energy particles and radiation from the sun can give Earth's computers a run for their money, Voyager 1's onboard computers aren't immune to the cosmic rigors. When one of those speedy, energetic particles decides to play tag with a computer chip, it can result in minor memory errors that accumulate over time. Susan Dodd, the project manager for both Voyager 1 and 2, puts it in cosmic perspective. She notes that such mysteries are par for the course at this juncture of the Voyager mission. These space pioneers have been on an incredible journey for almost 5 decades now, surpassing their expected mission lifespan. And let's not forget, they're treading through interstellar space, a high-radiation environment no spacecraft has ever ventured into before. Voyager's unbelievable discoveries in deep space. It's been almost 5 decades since Voyager 1 and Voyager 2 embarked on their epic journey, covering billions of miles, exploring uncharted territories, and making groundbreaking discoveries. These iconic probes, now well into their interstellar missions, are facing a unique challenge. Their computers, straight out of the 1970s, are running on a mere 70 kilobytes of memory. Yes, you heard it right, 70 kilobytes. Despite these ancient tech constraints, NASA has somehow managed to keep these distant sentinels alive. Imagine sending software updates across vast distances of space to ensure their continued operation. It's like playing cosmic IT support. As a result, in the pitch-black void of space, billions of miles from home, the Voyagers have crossed the threshold, offering us humans new insight into some of the biggest mysteries of our solar system. And hold on to your seats because the twins have just dropped a bombshell. Interstellar space is even weirder than we expected. In this world-shattering revelation, we're diving deep into Voyager's impossible discoveries after 46 years in space. Now let's take a moment to appreciate these space pioneers, the twin Voyager space probes. They're currently bidding farewell to the solar system, drifting forever among the stars. Picture this. Each probe is about the size and weight of a subcompact car. They're like the vintage rock stars of space exploration, epitomizing 1970s high-tech. Sure, their computers might be weaker than the ones in today's digital watches, and their analog TV cameras more primitive than those that shot I Love Lucy. But they made history on every planet they visited. Thanks to Voyager, we now know that Jupiter isn't just a serene giant. It's got hundreds of raging hurricanes, a glowing aurora at the North Pole, and 3 thin rings that turned out to be more complex than a fancy braid. Saturn's rings, once thought to be countable on one hand, surprised us with thousands of ringlets and seemingly braided components that theorists deemed impossible. And get this, active volcanoes, once an Earth exclusive, popped up on Jupiter's moon Io and, astoundingly, on Neptune's Triton, where nitrogen geysers erupted at a shocking 40 degrees above absolute zero on the Kelvin scale. But the real showstopper? Voyager unveiled 2 potential hotspots for alien life: Jupiter's icy moon Europa and Saturn's Enceladus. These moons seem to have vast, briny oceans beneath the ice, where living organisms could be thriving. But it doesn't end here. Voyager's faint signals from interstellar depths. The Voyager mission's most touching farewell was its poignant salute to its birthplace. Back in early 1990, the spacecraft captured a portrait of the Sun's family of planets, and within that frame was an iconic image of Earth. This idea was pitched by Carl Sagan, a key member of the Voyager imaging team and the mastermind behind the Golden Record, as early as 1981. He fittingly named it the Pale Blue Dot. In his book of the same name, Sagan expressed his motivation for this image. He drew inspiration from the famous Earthrise images of the Apollo program, specifically the one taken by Apollo 17 from the moon's surface. Sagan's vision was to provide another perspective, a picture of Earth taken from 100,000 times farther away. He believed that this image could contribute to revealing our true circumstances and conditions. While classical thinkers knew Earth as a mere point in a vast cosmos, no one had seen it that way until this moment. Fast forward to August 25, 2012, and Voyager 1, located a staggering 11 billion miles from the Sun, officially crossed the boundary into the interstellar medium. And guess what? It's still out there, transmitting valuable data. Its companion, Voyager 2, joined the Interstellar Club in 2018. These space pioneers are now so far from Earth that it takes almost 22.5 hours for a one-way radio signal, traveling at the speed of light, to reach Voyager 1. Voyager 2 isn't far behind, requiring nearly 19 hours. Every single day, these intrepid probes move another 3 to 4 light seconds away from us. Their lifeline to Earth is NASA's Deep Space Network, a trio of tracking complexes strategically placed around the globe, ensuring uninterrupted communication as our planet rotates. As our space travelers drift away into the vastness of space and time, their signals are like whispers that are getting quieter. Earth, with all its noise from radios, TVs, cell phones, you name it, makes it pretty challenging to catch these faint signals. Even though these whispers are faint, they match up with what astronomers expected as the Voyagers venture into the interstellar phase of their mission. This mission, a massive scientific effort that took about 10,000 work years, is often hailed as one of the most significant explorations by our species. But here's the interesting part. It almost didn't happen. The Voyager mission was a stroke of luck in celestial mechanics. First, Michael Minovich figured out that a spacecraft could borrow speed from a planet to shoot away from the sun. Then Gary Flandreau built on that, showing that probes launched in the late 70s and 80s could ride a special alignment of outer planets, jumping from one gravitational assist to another. Suddenly, Neptune at the edge of the solar system became reachable in just a dozen years instead of a whopping 30. NASA jumped on this golden opportunity, but tight budgets forced them to scale back the grand tour of the outer solar system. So, instead of a big-budget exploration, they settled for a more affordable visit to Jupiter and Saturn, still a $250 million journey. Now, researchers kept their fingers crossed for a detour to Uranus and Neptune. The theory was that if Voyager 1 aced its mission at Jupiter and Saturn, we could tweak Voyager 2's path to swing by Uranus and Neptune. Voyager gadgets and galactic voicemails. Now, let's talk gadgets. The twin Voyagers were decked out with all kinds of sophisticated equipment: cameras, infrared and ultraviolet spectrometers, sensors for mapping cosmic bits like charged particles and cosmic rays, and even a photopolarimeter and a magnetometer. Powered by nuclear energy, the Voyagers were initially expected to rock the space scene for about 5 years. But guess what? They defied the odds and multiplied that lifespan by 10. Fast forward, and the Voyager mission has become the stuff of legends, a daring trek to the outer planets and beyond. It's not just an expedition, it's a rite of passage, more mythic than scientific. The mind-blowing images of alien worlds that these spacecraft sent back were like a connect-the-dots puzzle for people worldwide, turning the mission into a historic pilgrimage into the unknown. And then there's the golden record, a true showstopper. Each Voyager carried a phonograph record loaded with images, music, and sounds representing Earth, including greetings in 55 languages. It was like a cosmic voicemail to any intelligent beings out there in the Milky Way, a hopeful shout-out across space and time. Imagine the thrill of thinking that extraterrestrial civilizations might stumble upon these messages, giving us a shot at galactic fame and maybe even a bit of immortality. The Voyager mission, with its never-ending journey and mind-blowing scientific revelations in our solar system, has become a symbol of our deep-seated curiosity about our cosmic existence. Its human-forward approach has resonated with participants and onlookers alike, embodying our collective longing to comprehend our place in the cosmos. For over a decade, thanks to the tireless efforts of these twin spacecraft, humanity has delved into the mysteries of interstellar space. NASA's probes in their exploration have not only provided valuable insights into our solar system, but have also revealed the strange and unexpected nature of interstellar space itself. Let's break it down. Contrary to the peaceful image of a burning ball of light, our sun is a dynamic nuclear furnace hurtling through the galaxy at a staggering 450,000 mph. Picture this: twisted, braided magnetic fields enveloping the sun as it orbits the galactic center. The sun constantly emits a stream of electrically charged particles known as the solar wind. Now here's where it gets fascinating. The solar wind doesn't just dissipate into the cosmic void. It collides with the interstellar medium, a collection of debris from ancient stellar explosions that floats in the spaces between stars. It's like the collision of oil and water, they don't perfectly mix. Instead, the solar wind creates a protective bubble within the interstellar medium, aptly named the heliosphere. Thanks to Voyager data, we now know that this heliospheric bubble extends a whopping 11 billion miles from the Sun at its leading edge. It envelops the Sun, all 8 planets, and many of the outer objects orbiting our star. This heliosphere isn't just for show. It serves as a shield, protecting everything within it, including our delicate DNA, from the majority of the galaxy's high-energy radiation. Imagine it as a cosmic force field, ensuring the safety of our solar neighborhood in the vast expanse of interstellar space. Cracking these cosmic puzzles requires a comprehensive understanding of the heliosphere. That's why NASA has been playing cosmic IT support, ensuring the longevity of these distant sentinels by beaming software updates across vast stretches of space. It's a bit like doing brain surgery on a patient located a whopping 15 billion miles away, not your typical Monday morning task. Voyager's software saga in machine language. Updating Voyager's software is no walk in the park. It involves sending new code directly to the spacecraft's computers, which are programmed to understand machine language, the most basic form of programming. In other words, the code needs to be written in a language that the hardware comprehends without the luxury of an operating system or any fancy programming tools. To tackle this challenge, NASA engineers pull out all the stops, a mix of ingenuity and resourcefulness. They resort to assembly language, a low-level programming language closely resembling machine code, to craft the update instructions. This approach allows them to have direct control over the hardware, ensuring the code operates as efficiently as possible. They also throw pseudocode into the mix, a simplified set of commands to automate repetitive tasks without gobbling up precious memory. Now, let's not mistake these software updates for mere bug fixes. They're lifelines for our intrepid spacecraft. Over the years, these updates have addressed a myriad of issues, from reviving malfunctioning components to fixing glitchy bits of memory. Picture this: a software update once saved Voyager 1 from a potential disaster when a hardware piece threw in the towel. The update triggered a fail-safe mechanism, giving the spacecraft a second wind to continue its cosmic mission. The Voyager missions weren't just a stroll through the cosmic park. They were like the launch pad for a whole bunch of interstellar adventures. These space trailblazers didn't just make groundbreaking discoveries. They lit the spark for even more exploration. So check this out. Voyager's peek at Jupiter revealed that it's one seriously complex planet. That got NASA all fired up, leading to the launch of the Galileo mission in 1989 and the Juno mission in 2011. It's like Voyager was the opening act for these cosmic headliners. But wait, there's more. Voyager's cosmic exploit inspired the iconic Cassini mission to Saturn. According to Jonathan Lunine, a big-shot planetary scientist at Cornell University, Voyager 1's close flyby of Titan, Saturn's moon, was the catalyst for Cassini's spectacular mission. Cassini even dropped a probe, Huygens, onto Titan's surface in 2005, sending back an incredible video. Voyager 2 wasn't sitting on the sidelines either. It kicked off investigations into the ice giant planets, not just in our solar system but also in distant star systems. Think about it. Most of the exoplanets we've found so far are roughly the size of Neptune and Uranus, and Voyager 2 played a part in that cosmic detective work. Now, fast forward to today. NASA's still riding the Voyager wave. The Dragonfly mission is set to hit Titan, Saturn's largest moon, in 2034. The Europa Clipper is gearing up to study Jupiter's ocean moon, first spotted by Voyager, starting in 2030. And get this, the National Academy's Planetary Science Doodle Survey recommended a $4.2 billion Uranus orbiter and probe mission in the 2040s. It's like a space rendezvous with the mysterious ice giant planet and its moons. And you know what's crazy? It all traces back to Voyager 2's quick visit to the Uranus system in January 1986. the cosmic farewell. It's been almost 5 decades since Voyager 1 and Voyager 2 took off on their epic journey, but we're still riding the cosmic vibes they set in motion. It's like a space-time continuous sequence of intrigue and discovery that started with those intrepid probes. Here's a mind-blowing update. Both Voyager 1 and Voyager 2 are still keeping the chatter alive with NASA's Deep Space Network. This network, designed originally to chat with Voyager 2 during its escapades at Uranus and Neptune, is still receiving regular commands and occasionally shooting back data to Earth. Talk about a long-distance relationship. Estimatio Primus, the principal investigator for the Voyager 1 and 2 probes and the Voyager Interstellar mission, spilled the cosmic tea during a news conference at Heliopause 22 in July. According to him, we're still soaking up data from Voyager, and the plan is to keep the interstellar party going for another 5 or 6 years. Around the mid to late 2020s, the scientific instruments on these space pioneers will be flicked off, and the spacecraft will go all cold and silent. Yet, their journey into the cosmic unknown will carry on forever. Primus, being in his 80s, cracked a cosmic joke saying, "My motto is, I want to be here after Voyager passes on, but I'm not sure that's going to happen." Get this, in about 300 years, both Voyager 1 and 2 will cruise into the Oort cloud, a space neighborhood filled with comets surrounding our solar system. Then, around 30,000 years later, they'll bid farewell to the solar system and quietly circle the center of the Milky Way for millions of years. Their scientific gig might be winding down, but these Voyager spacecraft are just getting started on their epic journeys into the cosmos. While the legendary Voyagers are off on their mind-blowing journey, NASA's Hubble Space Telescope, a cosmic veteran at nearly 33 years old, is still showing it's got some serious game. In a dazzling new image, Hubble has captured the forbidden glow of a distant spiral galaxy called MCG 012414, hanging out about 275 million light-years from our cozy Earth. Now, MCG 012414 isn't your run-of-the-mill galaxy. It's got 2 snazzy spiral arms and a lively glowing core, officially known as an active galactic nucleus, or AGN for the cosmic insiders. Imagine this galaxy doing a face reveal. It's seen face on, arms spread out in a nearly perfect circular shape. Now, MCG 012414 falls into the cosmic category known as a Type 2 Seyfert galaxy, one of the big shots in the active galaxy world, along with quasars. These galaxies flaunt a bright core, but are a bit stealthier compared to quasars, whose luminous AGNs can outshine their entire galactic homes. Now, what makes MCG 012414 extra special is its forbidden light. Hold on to your astrophysics hats for this one. See, spectra. The colorful patterns of light emitted by atoms and molecules usually follow some predictable rules. But in space, some spectral lines, dubbed forbidden emissions, break those rules. It's like a cosmic rebellion. Why are they forbidden, you ask? Well, on Earth, under the cozy rules of quantum physics, these emissions are so improbable that we usually ignore them. But in the wild, energetic core of a galaxy, all bets are off. The forbidden light gets its chance to shine out towards us, and that's what Hubble caught on camera. The photo, taken by Hubble's advanced camera for surveys, showcases MCG 012414 as the star of the cosmic show, with 2 bright foreground stars, one blue and one red, adding a touch of sparkle. And if you look closely, you'll spot more distant galaxies scattered against the inky backdrop of space. It's like a celestial masterpiece, reminding us that the Hubble telescope is still rocking the cosmic catwalk. Let us know in the comments section which aspect of the Voyager missions captivates your interest the most.